Hello, everybody. Here is your assignment. It requires you to empty your mind. Let go of everything you thought you knew. If this looks familiar, great. Still, let go and follow the steps. It requires an expansive mind. It will stretch you. Allow it to stretch you. But don't worry, I'm here to guide you. Step one, you must find a few things. Those few things are paper. I would say at least 2 or 3 sheets. A ball or other sphere. Any other sphere will do. Whether it's the ping pong ball, anything round that is a sphere shape. Anything. Any size really. The bigger the better. But even if it's like a little ball bearing, you'll still be able to use it. And you, of course, need a writing utensil, a pencil. And you probably need some tape. Go and get those right now and pause this video. Part 2 is, I'm assuming you have these now. You've paused the video. You have these. If you don't have one, you'll see how they're used, and maybe you can adapt and just use your mind instead to visualize it. These just help make it tangible and in front of you. If you don't have one, listen right now. If you don't have one, it's okay. Keep going. It just is going to stretch you a little more. It's easier if you have it, but it's possible to do this entire activity with just your mind. That's all you really need. These just help make it physical. So you have these things or not. Try to have them. It helps ease the stretchiness. What you will do if you have these items is draw on your piece of paper a dot and write the number 0 next to it. I'm just going to tell you that this is a 0-dimensional object. It's 0 dimensions because you can't go anywhere if you're there. If you're a dot and that's the only thing you know, you can't leave the dot. You can't go up, you can't go down, you can't go left, you can't go right, you can't go in, you can't go out, you can't go forward, you can't go backward. There's 0 degrees of freedom, and there's 0, therefore, dimensions. Now, if you have 2 dots and connect them with a line, the line can be straight or curvy, as we're going to see. It doesn't matter. It's still 1 dimension. So a line is a 1-dimensional object or space. Imagine you can only exist within the line. If you can only exist within the line, a fun way to do that is to draw an object. Draw a person or draw a character. Draw your favorite character. Draw an animal. Draw something or somebody that is moving along that line. And that person can go left or that person can go right. So you might say that's 2 degrees of freedom, but they're the same thing in the sense that you can only go along the line horizontally. You can only go this way or this way. That's 1 dimension. Because one of them is the opposite of the other, we consider that the same dimension. You can either go forward or backward. So that's 1 dimension. So if I have this point here and this point here, where when this person reaches this point, call that point A, it's actually the same as this point. Which means that if this person goes here, they magically appear here. How would you do that? You might say, oh, you bend it in a circle. The circle. So this is 1 into 2. This is a one-dimensional object that's now warped or bent into 2 dimensions. Our object, our person, our creature, our example can still only go one way or another, so they can't access the inside of the circle or outside the circle. That's the game we're playing. Say you can only access the line. So you can either go this way along the line or this way along the line. So this is a one-dimensional object wrapped in 2 dimensions, where this point is the same as this point. So you can go all the way around the circle. Why this is interesting is that if the person goes this way and say I have another person, draw another character. It could be the same character. It could be your friend. It could be a creature. It could be a dog. It could be a rhinoceros. It could be a cactus that can walk. So say you go this way, or your first creature goes that way, and the other creature goes that way. What happens? Where do you end up? So how you know something is warped in another dimension is that if you go one way, say you walked one way around the Earth, and say somebody else walked the other way, you might think you'll never meet each other again. But assuming you can walk on water and you walk in a straight line, what you think is a straight line, so I'm going to define straight as 1 foot in front of the other. So I have a foot and another foot, and I align them so there's no angle difference between the two. Now if I do this, and these people are just looking at their feet, what'll happen is they're going to dunk heads on the other side. Isn't that amazing? They don't notice that it's curved because they're just stuck on the line. But they would say, wait, it's you. Ah, I thought we were going opposite directions. So a one-dimensional object curved into 2 dimensions like this, you can do it other ways. Curved where you make this point equal to this point creates a situation where 2 opposite directions actually become the same direction. See why this is stretchy? And this is just the beginning. Yikes. So a circle is a one-dimensional object curved or warped into 2 dimensions. And we call it closed. So if 2 points connect, we call this a closed shape. Closed meaning if you walk in opposite directions, you end up walking in the same direction. Closed meaning it doesn't go apart, it comes back together. So it's like a closed room, you can't leave the circle. You can imagine an open. Open would be where this line continued forever, infinitely, in both directions. So an open line would be where if you walk this way, you just keep walking this way forever, and an open this way would just be that way forever. I'm going to focus on closed shapes today, but we'll introduce the open as we go along. Okay, you ready? So, all right, it's going to get weirder. Pause if you need to. So you have a sheet of paper. Imagine it's infinite. Okay, so this is a 2-dimensional object now, where you can draw a person or draw your favorite object, and that person can go left or right, And you have another person, so you can draw 3 characters. You can go up or down. And another character, again, you can draw kittens, you can draw elephants, you can draw anything else. I'm drawing people. You can go to diagonal. Now a diagonal is fun. A diagonal is a combination of right and up, for example. So if you have something going up and to the right, it's a combination of right and up. Those are happening simultaneously. The point is there's still only 2 choices. You can either go horizontally or vertically. Now pretend you're stuck in the page. You can't come out of the page. You can't go under the page. You're just in the page. So your drawing is like it's in the page. It can only go left, right, or up, down. That's 2 dimensions. We call it 2 degrees of freedom. But what happens if I roll the page? Same idea as the last one, isn't it? Where instead of having 2 points meet, I actually have this edge. Call it a different color. This edge is A, and this edge is also A. So what shape do we get? Well, now we get to practice drawing a 2-dimensional surface warped into 3 dimensions. And of course, we would get a cylinder. Here's how you draw a cylinder. You draw like a little oval that's like looking at a circle on the edge. And then you draw 2 parallel lines. Now what I like to do is draw the bottom of the oval and then the dotted line. It's supposed to be a dotted line, representing that so kind of like see-through. So this is my favorite way of drawing a cylinder. So drawing this becomes tricky now, which is why it's nice to have a sheet of paper and tape. So please make a cylinder. Pause the video. Take your sheet of paper, fold it together, and nicely and neatly tape the edge so you have a cylinder. And then imagine, you can even, on your other piece of paper, cut out a person or draw a person. You can draw a little person here. Or cut out a person that you can like move around. And that person can go this way or this way. Okay, so you're gonna have now, you want a flat sheet of paper, 1. Separately, you want another sheet of paper you rolled into a cylinder. I'll make a little list here. So 1, keep a flat sheet of paper that you imagine is infinite in all directions. 2, a cylinder. And 3, your ball. Now the ball is really fun because a ball is also a 2-dimensional shape folded in 3 dimensions. That you might say, hey, it's a 3-dimensional object. And yes, you're right, it is a 3-dimensional object. But if we focus on one part of the ball only, and that part of the ball is this, the surface. So if I draw a sphere, by the way, the best way to draw a sphere is to draw a circle, and then draw a circle on the side like this, with a dotted line in the back, and a circle on the side like this, with a dotted line in the back. Now, once again, this becomes tricky if you don't actually have a ball. So if you don't have a ball, you can still do this. You can imagine a person walking around your sphere. It's like being on the surface of the Earth. I can't go inside the Earth. Let's say I can't fly, so I can't go outside the Earth, so we're just stuck on the surface. So this is a 2-dimensional shell, the surface of a sphere. Sphere, surface. So there's 3 2-dimensional objects that I want to play with. Your assignment is to gather these 3 and to do a little experiment. What you're going to do is draw a person or a dot, just an object, on the surface of each. If you need to, your shell, you can just tape like a little creature. What I did with Juniper is we taped a little cartoon pig on the surface. Now imagine everything that happens is stuck in that 2 dimensions. You can't leave the surface, you can't go inside. So you can't leave the page. You can imagine it's infinite in all directions, but here you can't leave the cylinder, here you can't leave the surface of the sphere. So imagine 100 of these people walked in all directions. And then these walked in all directions. And then these walked in all directions. So you want a clean sheet of paper for this. What would the paths look like? Pause. Let that question make sense. So if I have what should seem like straight lines, and they walk foot by foot by foot by foot, and they walk what they seem in straight lines, if it's a flat space, those lines will stay straight and just go off in all directions. Draw that the best you can. So get a clear sheet and start over. Now draw it on your cylinder too. You'll notice that the lines sometimes will curve because the shape itself is curving. And imagine you're a little ant or you're a little creature, whatever creature you draw is going foot by foot by foot by foot. What would their path be? Draw as many as you can. Maybe like at least 10, 20, all in a circle like this. I drew like 8. Do more. Do like 20. Maybe color code them. Do the same on your ball. You can do it with like a piece of string or something like that. What would happen to those paths? The last thing, so that's it. The last thing you're going to do is this. Ready? So now that you've done that, you have your cylinder. Let's say I have point A here and point B here. Just a point there and a point there. How many paths from A to B are straight? Now remember, I define straight as you're on the surface walking foot by foot, so you might say it's curved. And yes, it's curved because the space is curved. But it's still straight by my definition of you're just looking at your feet, you're going straight one at a time. So paths from A to B that are straight. How many are there? And draw them. You probably already drew them in your last exploration. Paths from A to B, and then do it for the sphere. Let's say A is the North Pole, B is the South Pole. How many paths from A to B that are straight? By my definition of straight, I'm putting straight in quotes, because I'm redefining straight, or I'm taking a mathematical or physics definition of the word straight, meaning I just flip foot by foot by foot by foot, no misalignment with my feet, and I end up curving because the space itself is curved. One way you can imagine this, by the way, is that light rays, this is what we're gonna go with this, I'll just tell you, are stuck inside of the surface of these objects. And you shine a flashlight, you have a light bulb that's shining light in all directions. Eventually, what would the light do? It would curve around. So if you're standing here, this is kind of the bonus question. If you're standing here, what would you see? What would you see? If you're the only thing on the surface. Now I'll give you a hint. Light from you is leaving in all directions. And it follows a straight line. Where does that light end up? And what would you see? Bonus question. Please do it. Bonus meaning next level. You're going to do this. This is where we're going. Let's do it right now. We're right there. What would you see? That's your assignment. If you're the only thing on the sphere, you can do it for a cylinder too, by the way, if you want. In fact, do it for a cylinder too. do it for both. I have a cylinder and a sphere, and here I'm standing on the cylinder. Or you have your own creature, whether it's an ant or a rhinoceros, whatever it is. And light from you is going up in all directions, just like light from me is going up in all directions. You can see me over there, you can see me over there, you can see me there. But say I'm the only thing in this universe. This is like a universe. And light is going this way. Careful, it's not going off the cylinder. It's stuck on the cylinder. Because that's the stretchy part. You're stuck in the cylinder. So what would the light eventually do? And what would you see if you're the only thing in this universe? You and the light are the only things. So how many paths from A to B? What are they? And what would you see if you're standing on a point and the light followed the shape? Enjoy, gather these objects. You are amazing.